Unit 2, Lesson 2. Now factoring trinomials in the form of ax squared plus bx plus c. So today we're focusing on the a. Okay, the a is not 1 today. So that's the issue now. The a is going to have a 2, a 3, maybe a 5. Okay, something there in front. So to get started here, we're just going to practice kind of going through, and we're going to FOIL these out. Okay, and understand that they factor, like, we're going to be getting answers like this today. That's going to be our factored answers. So we're just going to look and see what this would give me so we know what it looks like if I FOIL it out. So 2x times 3x is 6x squared. 2x times 4x, or 4, is 8x. 1 times 3x is 3x, so that's 11x. Just adding those together real quick. And then lastly, the 4 times the 1 is 4. Then I'm just rewriting it here, a little tedious, but this trinomial factors to that. So remember, we're going the opposite direction of FOILing. We're factoring. Okay, same thing for B. I'm just going through these quickly because I feel like you guys are probably not very challenged with this. So 3x times 4x is 12x squared. 3x times 3 is a 9x. Negative 2 times 4x is a negative 8x. 9 minus 8 is 1. Negative 2 times 3 is negative 6. So then 12x squared plus x minus 6 factors to that. And again, that's what we're doing today. Okay, we're refactoring those uglier ones, okay, to different binomials. Okay, we're just going to do a real quick, just brief algebra tile stuff. I don't know if you remember algebra tiles too much, but remember these are x squareds, these are x's, and these are 1s. Like, that's 6 right there. All right, so for example, it says write a polynomial expression for the group of algebra tiles shown. So this would be 2x squared, 1, 2, 3, 4, 5, 6, 7x, plus 6. That's what the polynomial would be. And it says arrange the algebra tiles into a rectangle and state the length and width of the rectangle. So what it wants you to do is to stack these. And so we're not going to do a ton of algebra tile stuff, but this can help you with your visual understanding. So this is what they're asking. So here's a square. I'm putting it next to another square. Mine obviously aren't to scale. We're going to put 3 of them next here. Okay, and then we're going to do so look, I have 2x squareds, 1, 2, 3 x's, and then remember they're all this distance and this distance are the same, so I can match up x's this way too. This just kind of shows you how it's going to be factored, and you can kind of see with the pattern. Okay, you can see with the pattern that this is a perfect rectangle now. Okay, obviously mine's not to scale, but the pattern is, if you look, I have 6 here. I have 1, 2, 3, 4, 5, 6, 7, 8 here. Do I have 8? Or no, excuse me. 1, 2, 3, 4, 5, 6, 7 here. So that kind of like has to match up in terms of their multiples. But just a second here. This is just kind of brief, so if you're not understanding this, it's okay. It's more visual. But how this would be visually would be to make this side would have to be a 1x. To make these, since they're turned sideways, since they're sideways axes, what's this length here? A 1, right? So this is a 1 and a 1. So this side is x plus 2. That's what that side is. This side is x, 1, 2, 3. So this one is 2x plus 3. These two multiply to get that whole list there. And they're all dark, not white. If you want to shade them, you can. Okay, and so based off what we just did, they want us to represent that as a polynomial. So 2x plus 3 times x plus 2 equals what we had. Okay, to get away from Asbatalos here, we're going to go ahead and just skip number 2. You're welcome to do that if you want, or you can come back and just do that using our decomposition later. But since we're not going to be using Asbatalos a ton, I'm not going to spend the extra time to go over that. Okay, so factoring ax squared plus bx plus c using method of decomposition. So this is the main thing we're going to be learning today. Okay, yeah. You ready to do this? Okay. Sure. Okay, so we have, in warm-up, we factored, so we did this in the warm-up, we factored 6x squared plus 11x plus 4 to this. In order to factor 6 squared plus 11x plus 4, we must first split 11x into 3x and 8x, because this right here we're going to do. That's what AC is going to do for us. Okay? So what we want to figure out is 6 times 4 is what? Is 24. It's 11, right? What factors of 11, what adds up to 11 that are factors of 24? That's where the 8 and the 3 come into play for us. Okay? So the pattern we're going to be doing is we're going to be going first times last, okay? And we're going to break that down into a factor that adds up to the current middle we have, and we're going to break it up. Okay? So because we want to get 3x and 8x. Okay, and I'll show you why in a second. Any questions on just the initial? Okay, this is initial. Okay, but this is how do we split 11x and 3x? And how we split the middles up, essentially. Okay, and we'll get to that. So we know that 8 plus 3 equals 11. 11 is what our b is. Our b is our middle. We know that 8 times 3 is 24. Okay, and doing 8 times 3 is A times C. That's the front times the back. Okay, because 24 is what 6 times 4 is. That's not a coincidence. That's what I'm telling you. Okay, we're talking about the same thing for example 2 here. So 9 plus a negative 8 is 1. 9 plus negative 8 essentially equals what b is, because b is 1. Nine times a negative 8 equals negative 72. 12 times negative 6 equals negative 72. So these are equal. So AC is the same as multiplying the two numbers that get you B. Alright, so enough with the theory here. Let's go ahead and just try one. I'm more of a doer than I am an explainer, so again, if you have questions, slow me down. Okay, so essentially, we'll do a little checklist here. So, first thing, you want to multiply A times C. That's our first step for doing decomp. So I'm going to go 2 times 6 first. I hope through my somewhat gibberish we get that now. Okay. 2 times 6 is 12. Now I kind of write my 12 off here because we're not putting my 12 in the middle. We're not doing anything with a 12 other than using it to break the middle down. Okay? Any questions with that? Okay, so what I want to do now is I want to step 2, break AC down to multiples that add to B. Okay, so we're multiple of 12 that add to 7. Right, our 4 and 3. Okay, step 3, break B up, so that's a B, into those multiples. And our last step is factor by grouping. That's kind of the steps we're going to follow. Okay, so this is what I mean. Okay, I know you can't read this. So multiply AC, break AC down to multiples that add to B. So 4 times 3 adds to B. 4 plus 3 is 7. Okay, step 3, break B up into those multiples. So we're going to take this, and we're going to break 7 to 4x plus 3x. We're really not changing anything, other than we're just breaking up the middle to help us out. Okay? And then what did we do in our first lesson? Every time we saw 4 terms, we said we want to factor by what? Grouping. So I'm going to group these here and here. When you're factoring by grouping, you want a GCF. Okay? So what is a GCF here? 2x. So that's going to be 2x comes out. That gives me x plus 2 is left in. So I pulled the 2x out. Okay? 2x times x, 2x squared. 2x times 2 would be 4x. Okay? What does 3x and 6 have in common? The 3. Good. Now we're waking up here. That gives me x plus 2. So remember, these matched, so they can be 1. And then we push together, so your final answer is going to be x plus 2 times 2x plus 3. You're done. This is that factored. Okay, so we'll come around now and we'll each take turns doing the steps here. Okay, so start with you, Andrew. So what happened with the 2x and the 3x here? Right here. These push together to be their own binomial. So 2x plus 3 I put together as the other factor. Does that make sense? Okay, so Andrew, I want you to write that down. Step 1 for part B. So what is AC multiplied on number 2? 10. So 5 times 2 is 10. Okay, good. Carson, can you think of any multiples of 10 that add up to 7? Right, 5 and 2, the ones we just did. Okay, good. Okay, and then Nick, what do I do with that 5 and 2? Okay, just real quick, just so we know we're on the same page. That's correct, Nick. This guy right here, I don't really want to do red, but oh well. Okay, this guy right here, 5x plus 2x, it doesn't matter the order you put them. I like to put them with stuff they go better with, I say. So, for example, to me, 5x goes better with a 5. 2x definitely goes better with a 2. Okay, but you don't have to do that. Okay, you can mix them and you'll still get it right. Okay, because you'll still GCF. Okay, so now our next step, Connor, is to what? Group them. Good. All right, go ahead, Connor. So what's this have? Okay, you also want to take out a what then? 5x. Yeah, because we want to get rid of what the x is. Good. So it gives me x plus 1. And then what else do I want to take out on this one? A 2. X plus 1. So again, these match, so we know that we feel good about what we did. So then putting those together, Bethan, what would that be? Yep. 5x plus 2, x plus 1. That's it, factored. Okay. Good. Okay, so these steps are going to go away, so if you need them, get them down quickly. We're going to go ahead and try example 4 here. All right, so step 1. Wes, what'd step 1 be here? AC, which is negative 18. Okay, good. Evan, what are factors of negative 18 that gets you 17? Okay, we want a positive 18 because it's a positive 17. Okay, good. And Andrew, what do we do after that? Right, we're going to put them back in the equation. 18, where would you put that next to, the 6 or the 3? Doesn't really matter, but your preference. Okay, 6x squared plus 18x minus 1x minus 3. Okay, and then Carson, what do we do now? We group them, good. So group. Okay. Connor, what do they have in common here? 6x, so that gives me x plus 3. And what do they have in common in this one? It's kind of a tricky one. Yeah, just a negative. Okay, so whenever you see negative, you're going to pull out a negative, because we want it to be x plus 3, right? So we're taking out a negative 1. Okay, and we're done. 6x minus 1, x plus 3. Okay, good. Now, we haven't been doing it because there hasn't been any chance to do it, but we still want to check for GCF every time. Okay, there hasn't been a GCF, so don't worry, but we still want to look and see if we can GCF first. So don't ever forget our flow chart. GCF is always number 1. Okay, Nick, get me started on B here. Okay. Negative 6 and 4. Okay, good. What's the 6 go bear with, the 3 or the 8? Yeah, 3 is fine. Okay. All right, good. All right, Bethan, what do we want to do now? Yeah, group. Okay, and then go ahead and tell me what you're going to pull out of those two. Okay, and then 4. Okay, so we got n minus 2 is a match. We feel good. Our answer is done. 3n plus 4 times n minus 2. Very good. Okay, Evan, you want to start us on C, and Wes can finish it? Okay, good. And then factor 12 to get you negative 8. They'll both be negative. Yep, negative 6, negative 2. Okay, I'll probably put the 6 with the 12. Okay, now we're going to group. Okay, so Wes, what am I pulling out of the first one? 12x squared minus 6x. What's that? Not 2x, bigger. 6x, yeah, 6x. That gives me 2x minus 1. And what do I pull out of the second one? Kind of a tricky one here. Yeah, just take out a negative. Because it's opposite of what we want. We want a 2x minus 1. It's a negative 2x plus 1. So we just take out a negative to switch it back. And we're done. So I get 6x minus 1, 2x minus 1. Okay, very good. All right. Okay, let's get to example 5 here. All right, so we'll just keep going on these. So 15 minus 7y minus 2y squared. So Andrew, go ahead and start me on this one. Now it is written backwards, but we can still use the same process. Yep, negative 30. So we're still going to go 15 times negative 2, so that's negative 30. Okay, what are factors of negative 30 to get you negative 7? Anybody have it? Negative 10 and 3. Good. So that's going to give me 15. I'll probably go minus 10y plus 3y minus 2y squared. We're still going to group. Okay, we're still going to group. 15 and 10 have a 5 in common, so I'm pulling a 5 out of that. That gives me 3 minus 2y. These just have a y in common. Gives me 3 minus 2y. Those still matched, even though it's backwards. They still match, so we still feel good about it. So our answer is 3 minus 2y, 5 plus y. Okay, good. So B. Nick, do you see anything we can do on B that's been different? Yeah, we can GCF it. So what do they all have in common? Right, 15, 5, and 10 should be an alarm to you that you can pull a 5 out. So we can go 5 out, 3k squared now, plus k minus 2. Now we have a little bit easier, okay, a little bit easier decomp problem. Okay, we're still going to, now what you're going to do is what I like to do is, don't let this 5 bother you, just know that down here at your answer, you're going to have a 5 in the front. That's all you need to know. Otherwise, just ignore it, and we're going to factor this. So this is going to go 3 times negative 2 is negative 6. Factors of negative 6 that gives you 1 is 3 and negative 2. So I'm going to go 3k squared plus 3k minus 2k minus 2. I broke it up. Now we're going to group. 3k here. That gives me k plus 1. Negative 2 here gives me k plus 1. And we're done. 3k minus 2, k plus 1. Remember, order does not matter which binomial you put first, because it's multiplication. Any questions so far? I feel like you guys are all with me, so that's good. Okay, so let's get into example 6 here, so they change the game just a little bit. Okay, they change the game, but it still follows our pattern. All they've done is they've put a y squared in the end. Okay, but this is still in the same pattern. What I mean by that is, all this is, these are just going to be like x plus 2y times 2x plus y type problems. Okay, because a y times a y gets you the y squared, x times an x gets you the x squared. So nothing really changes in terms of what's new. Okay, so we're still going to follow our same rules. What is 2 times 2? 4. So I still have the 4 here. What are my multiples of 4 that give me negative 5? Negative 1 and negative 4. Okay? So again, stay with your same rules. Don't let this psych you out because it looks harder when it's not. Because all I'm going to do now, I'm going to go 2x squared. What's my middle, though? Is my middle x's or y's? It's both, exactly. It's xy's. So you're going to go 2x squared minus 1xy minus 4xy plus 2y squared. Now you're still going to group. And you're still going to GCF. So for example, in this problem here, what do they have in common? Just an x. Okay, not a 2, not a y, just the x's. So that gives me 2x minus y. That's my first factor. Okay, the second one, what do they have in common? Right, I'm going to go to negative 2. I always take out a negative if my first number is negative. So I'm taking out a negative 2y. Okay, that gives me 2x minus y. You see, even though it was more complicated and there's more variables, it still matched. This right here? Because I took out a negative, so that was positive, so now it's negative. Good question. Any other questions? So now we're done. Because look, these match. So we're good. So it's going to be x minus 2y times 2x minus y. That's your answer. Okay, I'm going to give you some time here. I want you to go ahead and try B on your own and see how you do. Okay, try B on your own and see how you do. Okay, so on B, what was kind of hard on this one was it was a little bit bigger of a number when we multiplied our A times C. Okay, our A times C got us 2 times negative 35, which is negative 70. So it's a little bigger than what we have been doing. So that gives me negative 70. But it's still at the same time, you should be familiar with 10 times 7. So it would be negative 10 times positive 7. That gives you the negative 3 in the middle. Remember, our middles are nm's. So what we're going to do is we're going to go 2n squared minus 10nm plus 7nm minus 35m squared. Now we're ready to group. So your negative 10 and your 7 in the middle we broke up, and now we're just trying to GCF. So these have a 2n in common. That gives me n minus 5m. The other one has a 7m in common. That gives me a n minus 5m. We're happy because those match, so we're done. 2n plus 7m, and then n minus 5m. And I'm not sure why math books like to put m and n's together, because that's confusing. Okay? All right. One last thing, which is easier than what we've just been doing, so that's the good news. We're going to be talking about perfect square trinomials. So, perfect square trinomial is a perfect square trinomial is formed by the product of two identical binomials. Perfect square trinomials can be factored by considering the pattern displayed when squaring binomials. So if you recognize perfect square trinomials, then you can easily factor them. Okay, and I'll show you what I mean. So complete the following. So if I squared this out, you'd get p squared plus 2pq plus q squared. If I just factored out, FOILed out, p plus q times itself. If I did minus, it would be p squared minus 2pq, and then plus q squared. That's a 2pq there, sorry. So they have a pretty similar pattern. The only thing that changes is the addition has addition in the middle, the minus is a minus in the middle. Everything else is the same. Okay? So it says from above we can see that the first term of the trinomial is the square of the first term. Okay, so the first term of the trinomial, p squared, is the first term squared. Okay? The last term of the trinomial is the square of the last term. Q squared is q squared. Okay, and then what do you think the middle is? Middle term is blank the blank of the first and last terms in the binomial. So first and last is p and q. So these are both 2pq and 2pq. Okay, so it's twice the product. That's the pattern. So it's going to be p times q times 2. Okay, p times q times 2. And why it changes, that's p times a negative q. So that's negative pq times 2 with a negative 2pq. Okay, so that's kind of your pattern breakdown. And now we'll just kind of talk about these here in a second. So in a perfect square trinomial, x squared plus 10x plus 25, the first and last terms must be perfect squares. So when you're going through these and says which of these following are perfect square trinomials, you can figure it out easily by looking at these front and back numbers. Okay? So for example, is 1 a perfect square? Yes. Is 4 a perfect square? Yes. So this one we can think, yeah, this could be possible. A plus 2 squared is a possibility. The only thing I have to do to check that, because a squared is a squared, 2 squared is 4, so we have those checked. How can I check the middle? What was our rule up here? Twice the product, right. Is a plus 2 times 2, what's that? So a times 2 is 2a times 2 is what? Is that correct? Yes, so this one's a yes. This is a perfect square trinomial. Okay, so Connor, what do you think on B, just looking at our rules? So first thing you have to do is look at the outsides. Look at your outsides, would you go further or would you stop? So what I mean by that is 1 a perfect square is 6, game over. It's not a perfect square trinomial because of 6. The 6 killed it. Okay. Nick, C, is 4 a perfect square? Is 81? Okay, so then we're going to start with what? What would your guess be? Okay, not plus 9, but minus 9. That's what our guess would be, right? It's minus because the middle is a negative. Okay, so let's check. Square root of 4 is 2. Square root of 81 is 9, so those are good. 2 times 9 is what? Okay, it's a negative 9. It's negative 18. What's negative 18 times 2? It's negative 36. So this one's a yes. So again, 2x times negative 9 is negative 18 times 2 is negative 36. Okay, good. And Bethan is D. What's D going to be? Okay, here's the problem. And you're right, we can test that if you want, but in order to have a perfect square trinomial, what's wrong with that one that's going to make it hard? Yeah, the 16 is negative. When this is negative, that means we have what? Different signs, so it can't be anything squared, right? So this one's a no. And you can circle that if you want, that's why. Every perfect square trinomial has to be a plus the constant. Okay, let's practice our pattern of figuring out the middle. So these are perfect square trinomials. They want you to fill out the middle. Okay, so I'll do the first one. So what's the square root of 100? 10. So we know this is going to be x and a 10. So then we know that the middle is going to be 10 times x times 2, which is 20x. That's how we're doing this. Okay, Evan, you want to take a shot at B? Yeah, minus 20x. The only difference is a minus. Same, good. Wes, you want to try C? Close. What's that? Well, what's square root of 25? 5 square root of 36. What's 5 times 6 times 2? 60. So I think you're missing one of them. Okay, so square root of 25 was 5, square root of 36 was 6. We times those for 30, times that by 2. Okay, this one here. So this one we got to do a little extra work because we got to figure out where the 24 came from. So we got to work backwards. Okay, so what's the square root of 9? Okay, it's what? 3, right? So that I know that my thing is to be 3 times something to get 12. Why am I saying 12 and not 24? Yeah, let's try 12 by 2. So 24 divided by 2 is 12. 3 times what is 12? 4. What's 4 squared? 16. Okay, just working on those patterns there. Okay, we're going too fast. We getting it? Almost done. Last section here. Okay. All right. So example 9 says factor. Okay. So 49 perfect square is 1. So let's try. That's a minus. Let's try 7x minus 1 squared. What I mean by try, I'm just going to check to make sure that's right. Okay. So 7 times 7 is 49. X times x is x squared. Negative 1 squared is 1. 7 times 1 is negative 7. Times 2 is negative 14. So that is correct. Okay. Andrew, you want to take a shot on B? What do you think B is? Okay. Plus just 5x. 4 plus 5x. Oh, you meant the whole thing squared. You're right. Whole thing squared. Okay, let's test it. So 4 squared is 16. 5x squared is 25x squared. 4 times 5 is 20. Times 2 is 40x. Good. Okay, fraction 1. Who wants to try the fraction 1? Okay, let me ask you this. Is 1/9 a perfect square? It is. Good, Andrew. It is because remember when this is from our radicals section. You guys had a radicals test, right? When you square root fractions, you square the top and bottom. Is 1 a perfect square? Is 9? 1/3. Okay, so I'll help with the fraction part. So we know it's going to be 1/3 a. What's the second part going to be, Carson? What do you think the second part, the last from the end? Yeah, so what's square root of 9? Right, and then the b, because it's b squared. Okay, so that's what it is. Let's test it. 1/3 times 1/3 is 1/9. That's good. A squared, yeah. 3 times 3 is 9, good. And then b squared. Now let's test the middle. What's 1/3 of 3? Somebody say it? Yeah, it's -1. So it's a negative, you're right. It's 1. Times that by 2, -2. So it's good. Okay? All right, and that is it for today. All right.